Alright, monotonicity is the property of a function that describes where it's increasing and decreasing. So if I have a function, we say it's increasing if I think about an interval. So we're going to talk about increasing on an interval. So we think about any 2 points in the interval, and I consider them to have an order. So x1 is meant to be on the left of x2. It's increasing if the point on the right is greater than the point on the left. And a function is decreasing on an interval if the same thing, if you think about 2 points, one on the left and one on the right, if the value on the right is below the value on the left. So those are the ideas of increasing and decreasing. So here's the picture. Let's see if I can draw this. So here's a point on the left, a point on the right. If the point on the right is always above the point on the left, it's increasing. But if I have the point on the right below the point on the left, then the function's decreasing. So when my function is an accumulation function that's defined with a rate, so here's my rate f, then I can think about the change in the function, which corresponds to going up or down, as an integral. And so if I think about the sign of my rate function, which is also called the derivative, then if this rate function is positive, I'll have a positive change, I'm increasing. If my rate function is negative, then I'll have a negative change and my function will be decreasing. So this slide summarizes that idea. Anytime I have a function that's defined as an accumulation, and I can identify the derivative or the rate formula f, if I can find an interval, so here's an interval AB, and my rate is positive everywhere in the interval, then that's enough to tell me that my function, the accumulation function, is increasing on the interval. And if I have a negative rate everywhere in the interval, then my function will be decreasing. Now notice in this that it says the interval is a closed interval, and that has to do with continuity. When you're doing the practice problems for web work, it's looking for open intervals, and we're going to be using parentheses here instead of brackets. We'll talk about that in class. Alright, we're going to look at an example. Here I've got a function g of x. It's an accumulation. I can identify its rate. It's the formula of this function inside the integral, and we're going to determine intervals where that function, the accumulation function, is increasing or decreasing. So here are the steps we'll do. First of all, we recognize that it is an accumulation, and we're going to identify the rate of accumulation, which is this function inside, and that's the derivative. We'll write that normally in terms of the original variable x. We're going to factor it, perform sign analysis, which is where we're going to decide where this function is positive or negative, and then we'll interpret that to decide where the function's increasing or decreasing. Alright, so we have our function, and this formula, the function that we multiply by the z, is our rate. So we write g prime of z is that formula, z cubed minus 3z squared minus 4z, and we want to normally think about that in terms of x, and so I've changed all of the z's to x, and here is my formula for my rate, or my derivative. Our next step was to factor that, so we're going to look at this and recognize that we have a common factor of x. So we'll factor that out, x times x squared minus 3x minus 4. And now I need to continue to factor. This is a quadratic. I can factor that. So our derivative is now factored as x times x minus 4 times x plus 1. And I have 3 factors. Last semester we talked about how to do sign analysis, and the way that we do that is we think about where this function equals 0. And so we have 3 factors. Each factor you might have either x equals 0, or x equals 4, or x equals minus 1. Those are the three spots where my function can be 0. So I'll put them on a number line. Those are all x values. We're going to look at the sign of the derivative, or the rate formula. And at each of those points, my rate is 0, and that defines a bunch of intervals. So we have 4 intervals. We've got to the left of -1, between -1 and 0, between 0 and 4, and bigger than 4. What we do to find the signs is we're going to pick values in each of the intervals and see what signs you prime it. So I'll do just a couple examples here. For example, I could pick -2, and when I calculate the derivative of -2, I get, in the factor form, -2 times -6 times -1. And I've got 3 negatives multiplied together, and that tells me that the answer is negative. All I need is the sign. I don't need the actual value. So I could do another example. Pick a number between -1 and 0, like -1/2, and I get a negative times a negative times a positive. 2 negatives and a positive and a positive sign. And as I do that for each of my intervals, I get my signs. And now I can interpret my result. So I have a negative value to the left of -1. That means that g prime of x is negative for the interval from -infinity to -1. And our interpretation, whenever the rate is negative, my function is decreasing. I'll be decreasing on that same interval. And I'll do a similar sign analysis for the other 3 intervals. And let me write that down, and you'll see the result. All right, so we had our 4 intervals. We had the rate was negative on the first interval, positive on the second interval, negative on the third interval, and positive on the fourth interval. And so we interpreted that as saying that my original function, the accumulation function, was decreasing on the interval -infinity -1. It's increasing on the interval -1, 0, decreasing on the interval 0 to 4, and it's increasing on the interval 4 to infinity. Now, technically, I could extend this and include all of these endpoints. I've been doing open intervals because the web work questions that you are looking for will be expecting open intervals, but they do actually extend to include the endpoints. So the question is describing the intervals where I'm increasing and where I'm decreasing. And so what I would enter into web work for increasing are the intervals -1, 0 and the interval 4 to infinity. And I'm going to separate them by a comma. And for decreasing, from -infinity to -1, as well as the interval 0 to 4. All right, the last example is to think about a visual example. So here I have a function, a graph, and this graph is my derivative. It's the rate formula. That would be the function that's inside the integral. So when I look at this, I'm thinking here about my axis, and I can see from the graph where the rate is positive, negative, and positive, simply based on whether my graph is above the axis, below the axis, or above the axis. And so this is all I need to be able to decide where my function is increasing or decreasing. Now, I don't really know what's happening after the graph stops showing, so I can't tell if it's going to keep going positive or negative. But what I can say, let's just have this extend out to 6 and minus 6. It's about where it's headed. So my function, the original function, that's the accumulation, f of x is going to be increasing on the intervals where I was positive, so negative 6 to negative 2, and also on the interval 2 to 6, and it's decreasing on the interval negative 2 to 2. We're not going to talk about the graph right now, but that's the essence of what we need. All right, good luck on the problems.